In the mass spectrum for the following molecule, what would be the m over z value, or the mass to charge ratio, for the molecular ion? So the molecular ion in a mass spec is the first ion that is formed. So what you have taking place, and so here we have our molecule. So if we were to take this molecule and put it in a mass spectrometer using electron ionization mass spectrometry, which is the only type that we will be considering, you would hit this molecule with a beam of electrons. So we'd hit this with an electron beam. And what that's going to do is it's going to knock one electron off of this molecule. So that will give us the intact molecule minus one electron, which means that it will overall have a positive charge and it will be a radical. And this initially formed, and it's lost an electron, so you can balance this by saying plus an electron. And this initially formed ion is what's known as the molecular ion. And since the charge of this ion is +1, and all of the fragments that we see in the type of mass spectrometry we're looking at will be +1, that means that the mass to charge ratio, the mass over the charge is +1, this number is always going to correspond to the mass. So this corresponds to the mass. So in order to know where the molecular ion would show up, what this mass to charge ratio value would be, we just need to know what the molecular weight of this molecule is. So we'll start by looking to see what the molecular formula is, and we can see 1, 2, 3, 4 carbon atoms. So we have C4, and we definitely see an oxygen. In terms of hydrogens, we can see we have 3 hydrogens on this end carbon, 2 hydrogens here, and 3 at the other end. And so we have C4H8O. And so when we're including the mass for mass spectrometry, we are going to use the most predominant isotopes of each of these elements, because what you're actually seeing is individual ions hitting the detector. So that means you're considering carbon 12. So for carbon, you'd say 4 times 12 for the carbon 12. For hydrogen, hydrogen 1 is the most common hydrogen, so we'd say we have 8 times 1. And then for for the oxygen, we have 1 oxygen, and the most common isotope of oxygen weighs 16. So if we do the math here and we add this up, so we would get 48 and 8 and 16. And if we were to tally this up, we would see that it weighs 72. And technically the units would be atomic mass units. So what we're looking at here then is the molecular ion showing up at 72.